So last time we talked about how to complete the square on a quadratic function in order to be able to graph it. And so if you want a reminder of that, I would go back to my previous video and I'll link that in the description. Today we're going to use that same technique to actually be able to derive all of the quadratic formulas that you can get for any quadratic function. And when we think of the quadratic formula, what we're usually thinking about here is the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And what that does is that helps us find the x-intercepts. So when we have a quadratic function or any sort of quadratic equation, we set one side equal to 0, and then we can use, so ax squared plus bx plus c equals 0. Okay? So we can use the coefficients of each of these in order to plug them into the quadratic formula and find basically the x-intercepts if I were to graph this function here. So let's actually write out just a basic quadratic function here. Let me move this to the side. F of x equals ax squared plus bx plus c. Okay? And I'll get rid of that. So what we're going to have here is we're going to have our desired quadratic formula that we're going to try to get to. And this is where we're starting. Well, in order to get our quadratic formula, remember that what we're trying to do is find the x-intercepts of the function. Well, the x-intercepts, the way that that is defined for any type of function, is the value of x when the output is equal to 0. So if you have any sort of function and you set f of x or the output equal to 0 and you solve for x, you're going to find where that graph either touches or crosses the x-axis, and that's for any function. So based on that definition, at some point we're going to set f of x equal to 0, but I'm going to kind of wait to do that until we go and complete the square here. Now remember from last time, in order to complete the square on something like this, we had actual numbers last time. Now we're just working with sort of arbitrary values or coefficients. But the same technique is still relevant here. Anytime we complete the square, we need to make sure that there is no coefficient on the x squared term. And in order to get rid of that, what we do is we take this coefficient and we factor it out. So I'm going to do that first. So using this first term, if I want to get back to the original term here, a times x squared is going to give me ax squared. And in order to get bx, it's a little bit tricky. Well, how do I get a b from an a? Well, I have to cancel out this a somehow so that I can get a b left over. And what I'm going to do here in order to cancel that out is multiply by b over a. A times b over a, the a's cancel out and I'm just left with b. And so a times b over ax is going to give me bx. All right, so I got that part right there, and I've got my plus c. Now that this coefficient here is free of the a, now I can complete the square on what's here in parentheses. And this might be a little tricky because you're working with letters now rather than working with numbers. So it might be a little harder to see kind of how to complete the square on this. But what we figured out by completing the square is we can do this by taking this term right here, dividing it in half, and then squaring it and adding and then subtracting that number to the right of this. And so if we think of half of b over a, well, 1/2 of b over a is just 1/2 times b over a, so that would just be b over 2a. And then if I square that, well, remember that when I use an exponent, and I have division, I can distribute the exponent to the top and I can distribute the exponent to the bottom. Well, that would be b squared. And then 2a squared, remember, it's the whole thing. So it's product to a power. So you would take 2 squared, which is 4, times a squared, which is just a squared, and you would get 4a squared. Okay? So this is what is going to be added and then subtracted. This is what actually completes the square on this right here. And so I'm going to write that whole thing out, and then I'm going to show you the next step where we can actually get the sides. Okay? So I'm going to multiply this by x squared. I'm just rewriting this part right here. And what we are adding to this is going to be b squared over 4a squared. And then I have to subtract that. And let's get rid of this out of the way so we don't confuse ourselves. And remember, add c. Okay, so now this right here is a perfect square. And if you remember the property, if you need to draw a box out for this, you can. But if you remember the property with numbers, this perfect square right here would basically be x plus whatever this is divided by 2 squared. So, and I'm going to switch to brackets here because I'm going to end up having some double parentheses. So this right here is now going to be x plus 1/2 of bax, or b over 2a x squared. And then I still have this minus b squared divided by 4a squared plus c. Okay? I'll draw it out here just in case you find yourself a little bit confused. If I wanted to complete the square on this, this would be x and x, so that would give me x squared. If I wanted these two boxes to add up to b over ax, I would have to take half of that. So it would be b over 2a and b over 2a. And so these two boxes here would be b over 2ax, b over 2ax. If you add that together, you get b over ax. And then b over 2a times b over 2a, or b over 2a squared, is b squared over 4a squared. Sorry, that's a little hard to see. So that's how I got this, okay? X plus b over 2a times x plus b over 2a is x plus b over 2a. Sorry, not x. X plus b over 2a squared, okay? All right, now I can distribute a times x plus b over 2a squared, a times negative b squared over 4a squared is minus ab squared over 4a squared. If you notice here that one of the a's is going to cancel out at some point. Okay, plus c. Let's go ahead and simplify that. A divided by a squared. The a on the top is now gone, and one of the a's on the bottom is now gone. So now I just have b squared over 4a. All right, so remember that this is f of x. Well, in order for me to solve this for x so that I can find the x-intercepts, I need to set the output equal to 0. So now this side of the equation is going to be equal to 0. Well, this is where my x is. If you notice, this part right here, these are all just constants. This is just going to end up becoming one number. And if you notice here, if you remember our transformation equation, notice how this looks very similar to this, because all I did is I just completed the square and I got to what we got previously, but just by using the letters rather than the numbers. Okay? So you can see a matches up with a, this is x minus h squared, and this is going to be whatever k is. So if you notice here, you can actually get from here to here by using some very simple formulas. And one of them is being able to figure out what this h value is. Notice here that this is x plus b over 2a. So if I wanted to get h, well, x minus negative b over 2a would give me this. So my h here would be negative b over 2a. So in order for me to find the x value of my vertex here, because remember that this h and k are the x and the y coordinates of my vertex, I can find out what the x is very simply just by taking the negative version of whatever this b value is and dividing by 2 times a, and it'll give me that x value. And you can see here that this would give me my output value as well, but rather than trying to remember that anytime I have an input, to find out what that output is, basically I would just plug whatever that value is into the original function and then figure out what the output is, and that'll give me my h and my k value. Okay, that will give me my vertex. So that's one of the first kind of simple formulas that you learn if you're trying to figure out how to go from something that is in standard form to what we call this like vertex form, is by finding where the vertex actually is. And then oftentimes we use this formula in order to find x-intercepts if we have them, and we can also plug in other points like I showed here. All right, now let's figure out how we get from here to here, because in order for them to be able to derive this quadratic formula, they had to follow these steps. Okay, I believe it was Al-Khwarizmi, who was an Arabic mathematician, and this was back in like the 1100s or something like that, or 700s, I think. But anyways, it was kind of during the time period of when Rome had sort of fallen, and a lot of the Arab countries had basically taken on a lot of these older works and translated them, and then also kind of added more knowledge to mathematics, philosophy, and other things before the Renaissance of the 1600s, and Europe again kind of led that effort. So anyways, in order for us to get from here to here, basically we need to solve for x when the output here is 0. And like I said, these are constants. So in order to move these over to the other side, I can subtract c, and I can add this whole thing right here. So by doing that, I'm going to get b squared, positive b squared over 4a, because I'm adding that on this side. And then I need to subtract c, so that's going to end up subtracting c on this side. And now all I'm left over with is a times x plus b over 2a squared. Okay? Before I divide by a here, or actually, I will divide by a. I will divide by a by multiplying by 1 over a here, and multiplying this by 1 over a here. Okay, so that's going to cancel out the a there and just leave me with this x plus b over 2a squared. 1 over a times this is going to get me b squared over 4a squared. And then 1 over a times negative c is basically minus c over a. So it actually was good for me to multiply by that 1 over a before trying to find a common denominator here. And then I have x plus b over 2a squared. Okay, now I'm going to find a common denominator. My common denominator between these two is going to be 4a squared. And in order to get that here, remember that in order for me to make an equivalent fraction, I need to multiply the top and the bottom by the same thing. Well, to get from a to 4a squared, I need to multiply this by 4a, because a times 4a is 4a squared. So I'm going to multiply both the top and the bottom of this by 4a. And what that's going to give me, let's just rewrite this. 4ac all over 4a squared. Okay? And notice that now that I have this common denominator, I can put the whole thing over 4a squared. And now I have this isolated on the right-hand side. Is that starting to look a little bit more like something similar here? I feel like we're getting quite close. Notice that in order for me to get inside the parentheses, I need to get rid of this exponent. And in order to do that, what I'm going to be doing is taking square roots on both sides. And when I take the square root on this side, all I'm doing is just getting rid of that exponent. Now remember that, and this is always something that can be a little bit tricky, but when you're taking the square root of something squared, there's a possibility of whatever is on the inside being a negative number squared, because a negative squared and a positive squared are both going to give you a positive value. So this could be either a negative value or it could be a positive value. There's two possible answers here because this is squared. So I have to write this plus or minus here on this side, and that's where you get the plus or minus from the quadratic formula. Because I took the square root of something squared, whatever here is on the inside could be either a positive or a negative opposite value. Okay, whatever value of x that gives me whatever that output is, that's positive or negative, needs to be included in this equation. That's why you end up with two possible answers for the quadratic formula. And notice that when I'm taking the square root over division, there's a property that says that I can take the square root of the top divided by the square root of the bottom. Well, the square root of the top, remember, I cannot simplify over subtraction or addition with a square root. So this top part is going to stay the same. So I'm actually going to move over here. So plus or minus the square root of b squared minus 4ac. But the square root over a product would be the square root of 4 times the square root of a squared. Well, the square root of 4 is 2. The square root of something squared is just itself, so that's a. So it's just 2a. And now, in order for me to just get x by itself, all I need to do is just subtract b over 2a. And when I subtract b over 2a on this side, I get negative b over 2a plus or minus the square root of b squared minus 4ac over 2a equals x. Notice that there's a common denominator here, so I can just put the top over one denominator. Negative b plus or minus the square root of b squared minus 4ac all over 2a is equal to x. Okay? So all I did was complete the square on this quadratic function. Now that I got it in this form, I set the output equal to 0 to to find those x-intercepts. I solved for x. I had to do a little bit of algebraic manipulation here in order to kind of get this to match up. But after I did all of this, I ended up with a simplified version of the quadratic formula, which is something that you use pretty much today and very regularly when solving quadratic equations and finding x-intercepts. So I hope that wasn't too confusing. If you need a little bit of a refresher again on this part, then I might suggest that you watch the last video doing this with actual numbers in there and get a little bit of practice with that. And then maybe you can start working with kind of the letters and understanding how this works. And then this part right here can be a little tricky if your algebra skills are a little bit weak, but hopefully this part kind of made sense about how we were able to get through this whole process by kind of just trying to find common denominators and use certain properties of algebra to be able to simplify this as much as possible. If you do have any questions about this, feel free to make a comment below, and I'll try to answer them as best as I can. If there's any other topics that you're either struggling with or just interested in seeing, I'd definitely be interested in seeing that in the comments as well. Be sure to subscribe, and I hope to make more videos like this in the future.